So, welcome back to the world of carbohydrates. And in this video, we're going to continue with our classification scheme that we started to discuss in the previous video. So, basically, to bring you up to par at this point in time, we have classified carbohydrates in a number of ways. In the first type of classification scheme, we called these things poly, hydroxy, aldehydes, or polyhydroxy ketones. And it really depends on what the sugar is carrying with it. If it's carrying an aldehyde group, of course it's called a polyhydroxyaldehyde. If it's carrying a ketone group, it's called a polyhydroxy ketone. So that was the first kind of classification scheme that we discussed. Next up to par was the new classification scheme of this thing called simple versus complex. And we said that a simple carbohydrate really is one carbohydrate, and that is it. We're talking about the structure of one carbohydrate. That is all that we're mentioning, and we're not really bringing into the picture other things that it might carry with it. So it is a standalone single bachelor in the world of carbohydrate chemistry. Complex carbohydrates are basically two or more carbohydrates that are hooked up, so they are somehow linked together, and that is what we would call a complex carbohydrate. It contains two or more monosaccharides that are hooked up with each other. So the way that we represent this, especially in the chemical literature, if you're looking at your textbook, is that one carbohydrate is abbreviated with a capital M. And M, of course, stands for monosaccharide, or a monocarbohydrate, if that's what you want to call it, but traditionally it's called monosaccharides or single sugars. That is what we refer to these things as. So a simple carbohydrate is a simple sugar. It is one monosaccharide, and that is it. In the complex family, well, we've got a monosaccharide that's hooked up to at least one other monosaccharide, and we can put in here ... because this thing can chain on millions, maybe, of molecules long. So that's the difference between a simple and a complex carbohydrate. So we're kind of building it up step by step. We're taking baby steps to get to that point. All right, in another type of classification scheme, we also brought in this definition of what we're calling a monosaccharide, which has one sugar on it, and we're looking at a disaccharide, which has two sugars on it. Then we talked about the word oligo, which is anywhere from 3 to 10 sugars. And then we talked about a polysaccharide, oligosaccharide. These have 10 or plus sugars on them. Alright, so that's another classification scheme that we can use. Look at the number of sugars that are hooking up and holding hands, and we can kind of describe on how many saccharide structures there are. So if there's one, it's a monosaccharide. If there's 18, then it's going to be classified as a polysaccharide. If there's 7, then it's going to be classified as an oligosaccharide. So that's another part of the object of this lecture, because we just want to feel comfortable with the face of the carbohydrate in the beginning. All right. Now finally, the new classification scheme that we haven't talked about yet deals with the number of carbons. So we can actually go and look at the number of carbons in a carbohydrate. And we can classify these carbohydrates based on the number of carbons that they have. And what we do is that we use a prefix with the ending of "-ose. And the prefix tells us how many carbons there are in that structure. So for instance, if I have a hexose, then hex means 6. So that means that there are 6 carbons in the structure of that carbohydrate. Okay, well, if there's 5, we would use pent. right? So the way that we do this, 1 is going to be for mono, 2 is going to be a di. Then I go to 3, and we can use the word tri there. So monos, dios, trios. Then 4 is going to be tetra, so tetros. 5 is going to be pent, so this is pentos. 6 and 7, of course. 6 is going to be a hexos. 7 is going to be a heptos. Now, in actuality, there's not really such thing as a monos. So a 1 carbon sugar, no, nothing really like a 1 carbon sugar. A dios, yeah, we can maybe use that word, but traditionally there's not really anything as far as a dios is concerned either, so we'll cross that out as well. So what we will see most often is the word tri through hept. We don't really go any further than a 7 carbon chain when it comes to these sugars. We keep them very simple, and we don't really go anything lower than a 3 because we're not really talking about sugars anymore. So 3, 4, 5, 6, and 7. Triose. Let me go ahead and write those out here to the side. Triose. 4 is tetros. 5 is pentos, 6 is hexos, and 7 is heptos, right? So you've got to be comfortable with the classification schemes before we go any further. So once again, just another way that we can maybe identify a carbohydrate that we have on hand. So let's do an example. Let's kind of put all of this to work. So let's say that we've got a carbohydrate that looks something like this. We get a C double bond OH at the top. That's connected all the way down, and then at the bottom is a CH2OH. So we're going to do a shortcut here. I'm not even going to draw the number of carbons here in the backbone. The only thing that I'm going to do is draw a straight line all the way across, because it's just like all the other organic chemistry structures. That point of intersection is understood to be a carbon. So let's say that we have an OH to the right, and let's say here we have an OH to the right, and let's say here we have an OH to the right as well. And this sugar, if you're curious, is called ribose. Now, we've not taken a look at actual structures of sugars yet. We're only classifying them. That's all that we're doing. So that's to come. But for now, that's sugar. It's called a ribose. So let's go through our classification schemes and kind of name it. Well, is it a polyhydroxy aldose or is it a polyhydroxy ketose? Well, the answer to that question is this is the aldehyde functional group right here. So that means that this is a polyhydroxy aldehyde. Okay, so that was easy enough, right? And they should be. You should be able to take a look at these structures and say that is an aldehyde functional group. So what I have here is a polyhydroxy aldehyde. All right, so there's the first classification scheme down. Number 2, is this a monosaccharide? Is it a disaccharide? Is it a polysaccharide? What is it? Well, this is just one sugar. That's all that this is, one sugar. It has a 6 carbon, or it has a 1, 2, 3, 4, 5 carbon chain on it, but it's not hooked up to any other sugar. We have said this sugar is called ribose. It is a polyhydroxy aldehyde. That is it. It's not hooked up to anything else. That's all that there is to it. Okay, so that means that this thing is a monosaccharide. So monosaccharide. Okay, now we can kind of go through and talk about, well, what kind of ose is it? Is it a triose, tetraose, pentose, hexose? What is it? Well, we've already kind of discussed that as well, right? This is my first carbon, this is my second carbon, this is my third carbon, there's the fourth carbon, and here's the fifth carbon. So there's 5 carbons in total with the structure. So that means that this is a pentose. So that's as far as we will go with at least the early on kind of classification scheme that's there. I will say that this gets modified slightly, not much, but for instance here we know that it's a aldehyde form and there's 5 carbons on it, so don't be surprised if they use the prefix Al for aldehyde, and then we put on the number of, I'm sorry, not the Al, but ALDO. And then we put on it the number of carbons that's there. So we can call this an aldopentose if we want. And that kind of kills 2 birds with 1 stone, right? We talk about the aldo, so we know it's an aldehyde. That's a check mark. And we know that it's a pentose, so there's 5 carbons there, so there's a check mark. So we kind of tackle both of them in one run by calling it an aldopentose. Now, if this was a ketone, just for some strange reason, if we did name it as a ketone, it would be the same thing. We would use the form keto out in front, however, instead of aldo. So keto pentose is the proper term that we would use if it did have a ketone functional group on it. So aldopentoses, ketopentoses, it's all about nomenclature. Once again, organic chemistry is like a foreign language. A lot of times you got to learn the vocabulary before we go a little further, and this is the vocabulary that we're building up in the very beginning of the chapter and the lecture. So welcome to the world of carbohydrates. Classification scheme, I think, is pretty much finished. And now we need to take a look and go back and talk about stereochemistry. So we're going to look at R and S again. We're going to look at rotation because these things are very important when it concerns sugars. So in the next video, stay tuned, we're going to bring back R and S. So R and S, the sequel, coming up.